All right, welcome back. Today we're going to conquer the feature of closure or Lisp that everyone wants in modern language are just getting is macros. Um, so I decided to try something different and I went into Claude Cowork and I said, give me a prompt for Claude Code to implement macros for Swish. They should behave just like closure macros. Make sure to implement good macro hygiene. Use gensym to generate unique symbols when evaluating the macro. Ask any clarifying questions you need. And it came back, it did a lot of work, and it came back with some questions. Should the prompt include implementing defmacro as a special form or in terms of def? And I said, do it as a special form. What syntax quote feature should be included? I said it should include all of them, which included auto-generating symbols. That was recommended. And then should macro expand and macro expand be included for debugging? And I said, yes, include both. Those are functions that expand a macro. And it generated a prompt to put into, actually it generated a prompt and then it came back and said one thing worth flagging, the prompt assumes fixed array macros. If you want variadic macros, which I do, you'll need to tell Claude Code to implement. So let me know if you want to add that. So I did, yeah, add that, and it updated it. So now here is our prompt. That we're going to put into Claude Code. And it's a long one, so I'm not going to read all of this, but we'll skim it. Implement macros for Swish that behave like closure macros. Macros are functions that run at expansion time on unevaluated code, receiving EXPRST nodes, not runtime values, and returning new code that then is evaluated. So there's like a double evaluation that goes on with macros. This is the key difference from regular functions. Macro arguments are not evaluated before passing to the macro body. Read Claude.md and SwiftMD before writing the code. What to implement? So it's going to add a new EXPR case, which represents our macro, and make sure equatable is implemented. Add variadic parameters for our past fn expression, as well as macros, because we will need those for a lot of macros. Then it mentions these macros that do that. There's the syntax for variadic. So then it's going to say in the parser, when evaluating fn or defmacro param vectors, allow the symbol at followed by exactly one more symbol, and that's for variadic arguments. Add parser error invalid function for that. In the evaluator, when creating a function or macro from a param vector, detect whether at is present. Split into fixed params and rest params. Store this info. You have options. Option A, recommended keep that in the params array at call time detect. Option B, add a rest param field to function macro cases. I think I like option A, which it recommends. Add macro function macro call times, check params. If yes, bind params, permission yes. Collect them into a list. Yes, arity check. They must have the right numbers. If no, okay. Here's the implementation for that. For call site binding. Okay. Trying to see where call environment came from. I assume that's earlier. This applies both function and macro. Update checked undefined symbols. Implement the def macro special form with the syntax. Support variadic params like that. Those it gives some good examples. In the parser, add parser invalidation. Okay, and the evaluator, when the head of a list is defmacro, extract the name created macro value stored in environment. Yes. Return symbol. All right, yeah. Macro expansion of call site. When evaluating a list and the head resolves to a macro, evaluator must do not evaluate the arguments. Create a child environment with the macro parameters bound to the unevaluated argument expressions. Evaluate the macro body in that environment. This produces the expanded form. Then evaluate the expanded form. Exactly. This is the fundamental difference between function calls. In the existing function call code, args evaluated for macros. Skip that step. Place the macro dispatch before general function call code in the okay, yeah. Gensym function. Register a native function gensym in core.swift that generates unique symbols to prevent variable capture in macro expansions. So what happens when you have a macro expansion, if there's if you've named the parameters like a, b, and that a, b occurs in the outside of the macro, then when the macro code gets generated, it'll assume that it's using the outside variables rather than the ones that are defined in the macro. So to fix that, you generate unique symbols for each of the parameters and use that in the body. And that's what they're talking about here. So it's going to add an atomic counter, because typically you just create unique numbers for these symbols. So it's going to generate gensym. Then we're going to put auto gensym in the syntax quote, right, which is what Clojure does. So you can have like a pattern like foo pound, and it'll generate a unique symbol that starts with foo. Okay. Macro expand. Okay, then it's going to implement these two functions. Macro expand one will do one round of expanding a macro, because a macro could itself have macros. So there's a recursive process that goes on. Macro expand will completely expand a macro. Macro expand one takes a coded form of the form of list, and the head resolves to a macro expand at one step. Call the macro body on the end. Otherwise, return the form unchanged. Note, macro expand one needs to call. Okay, this means the cleaner approach. Extract a helper method. Okay, then this value method. Macro expand one. Macro expand uses macro expand one. That makes sense. Here's more examples of defmacro and macro expand one. Update check define symbols for the defmacro spec form. Update the REPL. No changes needed, but the REPL has a special case for displaying. Make sure macro values. Okay, yep. Files to modify. Test to write. Parser test to add. Implementation order. Key correctness. Marco abs are never evaluated. This all sounds good, much better than I could write. So I'm going to copy it in, and let's fire up Claude here. All right, I just upgraded Claude, so I don't know why it's telling me that again. We're going to planning mode here. Paste our prompt and let it go. I chose to do macros right now because a lot of the functionality in Clojure, a lot of the things that you think are functions or part of the language are actually macros. So macros are a good first step that we need to implement some things, including like defen. I expect this will probably take a while. All right. right, still reading things. It's ready to write the plan. Our prompt pretty much had the plan, so be interesting to what it adds to that. All right, here's our plan. And it is a long one. This is probably our most ambitious prompt yet. Swish macros they run at expansion time on returning a new note. Then evaluate this plan at yep. Everything we talked about before in our original prompt. Add a macro case, add equatable, add errors, validate the param vector, current f, okay, replace with shared validate call, okay, add defmacro validation, also update fn validation, print out macros properly, gensym, bind params helper, macros are self-evaluating, add def macro special form and eval, add macroexpand 1, add macro dispatch. Wait, looks actually macroexpand 1 looks up the macro by symbol name. Since we already have a callee, we should call expansion directly rather than resolving. Simpler approach. Check if callee is a macro be calling. Okay. Place this before. Okay, yeah. Because we need to evaluate macros before we call functions. Because macros need to have that double evaluation that goes on. We're going to update syntax would expand for auto gensym. We're going to handle variadic parameters, register gensym and macroexpand 1 and macroexpand note must be internal, not private on evaluator. Since core Swift is in the same module, internal is fine. That's okay. Test implementation order verification. All right, I think I'm going to go for it. Let's auto accept exits. And here you can see how macros work. We define this def macro unless, which is really just negating the case. It's like an if, except it negates the case. So it reverses puts the then case as the else case. So unless false 42, then you can call it like that. And if you expand the macro, you can see that it reverses the else and the then part. And also we have gensym with and without a template. Okay, it's going to start implementing. It's looking at the package.swift. For some reason. The prompt I used in Claude Code, it was using Opus. And I think in Claude Code, I should say Claude Cowork, we're using Opus. In Claude Code, I think we're still using Sonnet. But you can see we're updating the parser. Now we're updating the printer. Now we're going to update the evaluator. Taking a long time on the evaluator, but it's implementing everything that it's said it would. Adding gensym and macroexpand functions. Now it's running the tests. The current test, it hasn't added any test yet. Now it's updating the REPL. Again, running the test to make sure everything's working. All right, the existing test passed. It's going to write some new tests. All right, it's updated the evaluator tests. Now it's going to add some parser tests. We're getting up to our limit. For the first time ever. It's probably because I used codework. If we do reach our limit, I'll just pause and then continue the video and put them together into one video. It has to add support to Lexer for handling the ampersand character, it looks like. We're at 99% of our limit, but everything is passed. Looks like we might be done. All right, so let's run the test manually. Everything runs. All right, let's see if I can do a macro. So if I say defmacro, let's do unless, which is one of the passes. So unless is going to take a condition and a then. Oh, let's do something simpler, like we'll just define defin for now, which will take, let's just say it takes, for simple thing, I'll just say it takes an x parameter, or a function, a name, and a value. And what we want that to do is we want it to become def with the name and then the value. This is not how defin works, but I'm just trying to simplify things. So actually we want to put in the name here. And add in the value. Whoops. Oh, that doesn't look good. may have to come back with this. I'm going to pause the video right here, and then when I do come back, it'll just be one video. I'll just add on to this. So see you in a bit. All right, I'm back. I did some more entering of macros in our REPL, and we get some weird errors, like first argument on this one, the def must be a symbol. And likewise in this defn down here, first fn requires a parameter vector. So it's almost like it is evaluating those things even though they're in a syntax quote. So I'm gonna enter that into Claude here. There seem to be some bugs in the REPL when I enter defmacro, defn, etc., etc. I get an error that says first argument of def must be a symbol. It appears it's trying to evaluate the def even though it is inside a syntax quote. Likewise, when I enter defn, defmacro, defn, name args, body, etc., I get an error that says fn requires a parameter vector, which again seems it's trying to eval the fn even though it is inside a syntax quote. So let's do that. Turn plan mode back on. I did hit my limits, but Claude, in the past week before they gave me a coupon to get some more credits on them. I think they had some issues that they gave credits to people, so I redeemed that, and we're back in business. Okay, looks like it was right. The parser is eagerly validating defn in syntax, even inside syntax quote templates, where the forms won't be direct. The fix is to skip validation inside syntax quote context. I'm surprised it'd be even doing that in the first place. Okay. Yes, go ahead and allow all edits. And the test passed. It's going to add a test for our exact scenario. All right, let's try this again. Let's look at it. Okay. All the tests pass. Let's run that again. All right, so defmacro, defn, it's going to take a name and some params and a body. This isn't the most accurate definition of defn, but we'll do that for now. And this is going to be def with the name, fn, params, and body. All right, so if we type defn, it's going to type the macro defn. And if we do a macro, let's use a defn hello. It's going to take an S, and we're just going to print S. There. So type hello. It's an FN. Let's try macro expand hello, or actually defn test XX, and now it's going to macro expand that, and we should get def test as an fn of x. All right, that seems to have fixed the problem. So now we have macros. we'll be continuing to refine this and going forward. The next step is to maybe add namespaces and places where we can put some code that would get loaded at runtime, that we could actually write some of our functions in actual Swish instead of having all native functions. So again, I hope you like that. Please like and subscribe. And there's also a link in the notes about buy me a coffee. So buy me a coffee if you'd like to support my work. And please comment below what you'd like to see more of. Thank you.